Okay, so part A, our big concept here is if we take the integral from a to b of f prime of x, that we get f of b minus f of a. And this is called the fundamental theorem of calculus. It's just something we have to memorize. It's kind of that integral of our rate is equal to the amount of b minus the amount of a. So we're going to use that here. We're going to separate those two with the plus. So integral from 0 to 1.5 of 3 f prime of x plus the integral from 0 to 1.5 of 4. And that gives us, we're going to use this concept. So 3 times f of 1.5 minus 3 times f of 0. And then plus the integral 4 is 4x from 0 to 1.5. So we're going to use the table, right? Look at the f row. F of 1.5 is negative 1. So 3 times negative 1 minus, look at the table again, f of 0, right, gives us negative 7. So with that, and then plus 4 times 1.5 minus 4 times 0. Maybe put a big parentheses around those. So that gives us negative 3 plus 21. And then plus 4 times 1.5 is 6. So that's negative 18 plus 6, which is, positive 18 plus 6, which is 24. So that's part A. All right, part B is a tangent line question. So as soon as we see tangent line, we think x1, y1, and m. And it tells us to use x equals 1. So for y1, this is f of x, right? So we look at f of 1, and that gives us 4. Then for m, this is f prime of x, so f prime of 1 is 5. So this gives us the equation y minus 4 equals 5 times x minus 1. If you look at the answer key online, they move the 4 over. This is full credit here, that's fine. Then use this to approximate f of 1.2. So for f of 1.2, we plug that in for x. So it gives us y minus 4 equals 5 times 1.2 minus 1, which is y minus 4 equals 5 times 0.2 is 1. Add the 4 over, y is equal to 5. And I'm just going to rewrite this as f of 1.2 is approximately 5 because that's kind of what we solve for. And then approximately because it's an approximation. To figure out, is this greater than or less than? Another way that that's asking is basically that greater or less than is saying, is it an over or an under approximation? So we need to check, right? Concave up would give us an under, concave down would give us an over. So we need to know like the second derivative of this. Well, we don't have the second derivative, but like in the table, but what they did tell us is they did tell us up here, the second derivative has the property where f prime, double prime, like the second derivative is positive, so it's telling us it's concave up. So we can use that. So what we can basically say is f double prime of x is greater than, f double prime of 1.2 is greater than 0. That they told us that. So we could kind of say something like because f double prime, or because of that, right, we would say that f of 1.2 is concave up, and therefore if it's concave up, it's an under approximation. So we would say that our approximation is less than f of 1.2. All right, part C asks us to find some value of C. Usually when we start reading this, we're thinking like mean value theorem, Rolle's theorem, intermediate value theorem, where f double prime is equal to r. And it's saying find that number r. So this is going to be mean value theorem, which is normally f prime of c equals f of b minus f of a over b minus a. However, on some of these table questions, they kind of do this with f double prime of c. So what we can do is we can kind of just rewrite this as f double prime of c would equal f prime of b minus f prime of a divided by b minus a. And so that's going to be f double prime of c which is what we're solving for. They said that's what r is going to be, equals f prime of, now our values 0 to 0.5, so f prime of 0.5 minus f prime of 0 over 0.5 minus 0. So that gives us f double prime of c equals, now f prime of 0.5, right, this derivative is 3. F prime of 0 is 0, so this is going to be 3 minus 0 over 0.5. And I'm just going to rewrite this now as r because that's what they defined it as. 3 divided by a half is 6. So there's that. Our reason, it says give a reason for your answer, is this did say it was differentiable. So our reason is, the mean value theorem, right? F is continuous and differentiable. So that's kind of that. Okay, D to me was kind of the weirdest one. It's asking, could this be true? There are a few different ways you could solve it. One way is we could check, like, okay, is this even continuous or differentiable? So if I plug in to the top, 2 times 0 squared minus 0 minus 7, I get negative 7. If I plug into the bottom, I get negative 7. So f of 0 is negative 7. It exists. That's that first rule, right? That for continuity. The second rule is, does the limit exist? So the limit as x approaches 0 from the left side of f of x, right? Which we actually kind of did this. So, if we checked both of them and they're both 7, that's kind of telling us it is differentiable. Sorry, it is continuous. But I didn't really write out the 3 rules. That actually kind of is the 3 rules. So I checked, like, right, the limit on the left, the limit on the right. This was the equal one, so they're the same. So basically this is continuous. It's kind of a crappy explanation. We could also check, is it differentiable? So g prime of x would be 4x minus 1 when x is less than 0, and it would be 4x plus 1 when x is greater than or equal to 0, which means that g prime of x would be basically negative 1 on the left as it approaches on the left, and g prime of x, or 0 would be positive 1 when it approaches on the right side. So what that's telling us is g prime of 0 is d and e. However, this said it's differentiable for all real numbers. So that means because f prime of x exists for all real numbers, f of x can't be g. Another explanation that I saw in the answer key was you could have done something like the second derivative, which is 4 on the left side and 4 on the right side, which means that g double prime of x is equal to 4 always. However, what we solved for in C, in part C, we showed that f double prime of x of some value c was equal to 6, so those can't be the same. This is kind of a weird one. It's kind of just thinking outside the box. You just kind of have to really think of some stuff that you knew about f or f prime. Think of some stuff for g or g prime by kind of taking the derivative here and seeing what we can do. Anyway, so there's that one. Try your best on the other two. Let me know if you have more questions.